Let's suppose that we have a circle with a radius of 100 and a line with a dot at the top. When the line is vertical, the x position of the dot will be 0, and then as we rotate the dot around the circle, it will get further and further away from the vertical midline of the circle, so that when we reach an angle of 90 degrees, the dot will be the farthest distance midline of the circle. As we continue, the dot, as we sweep through 90 through 180 degrees, goes back the other direction so that its horizontal distance from the vertical midline of the circle decreases until it reaches 0 again at 180 degrees. As we continue, it moves into the negative until it finally reaches minus 100 at 270 degrees, and then we begin moving back towards 0 again until an x position of 0 when the line is vertical at 0 degrees. Essentially what we've done is rotate through a series of sine values. Mathematicians use a circle with a radius of 1, but that would just appear as a dot on the screen of the snap stage. So we've used a radius of 100 to make it easier to see. We can create a list of these values by adding the position of the dot to a variable named cycle as we rotate around the circle. And this gives us 24 values, letting us see that as we go from 0 to 90 degrees, the x position of the dot gradually increases to 100 and then goes back the other way, just as we've seen. If we graph all of the samples in a single cycle, we wind up with the very familiar shape that is a sine wave. We can use these values to generate a tone, but one cycle won't be sufficient. In this case, we've created a variable named 200 cycles, and by repeatedly appending the first cycle to this new list, we can gradually build up a list of 200 cycles. Since there are 24 samples in each cycle, we wind up with 4,800 items in our list of 200 cycles. We can play this list of 200 cycles of the sine wave, but the values are too large to send to the computer speaker. The map command can apply an operation to an entire list. So if we apply times 0.001 times the list, then we get a much smaller set of values. So if we apply this to the variable named tone, then we wind up with the same items but shifted several decimal points. We can now play the sound samples of the sine wave that we've generated in this manner. When we play the sound back, it sounds like a 200 hertz tone. That's because we're playing it back at a rate of 4,800 samples per second. Since we have 4,800 items in the list, it'll take exactly 1 second to play the list of samples. And since there are 200 cycles in the list, we got a 200 cycle per second tone. By way of comparison, the note A over above middle C that orchestras use for tuning has a frequency of 440 hertz.